Okay, in this presentation we are going to look at a probability question. We are going to look at cola brands, okay? So this is a short enough question and it's just really to emphasize a couple of key points. So we're going to just sort of get straight into the question. Considering the following probabilities for a survey about beverage preferences amongst individuals. Let P be the event that an individual drinks Pepsi and let C be the event that the individual drinks Coca Cola. We're told that the probability of P is 0.72, the probability of C is 0.24, and the probability of A intersection C is 0.12. Okay, that's what we're told. Okay, calculate the following. Calculate the probability that an individual drinks both brands. Calculate the probability that an individual drinks neither brand. Are P and C mutually exclusive? Are P and C independent? Okay. So, if you're reading at this and you're looking at this and you're thinking, what's this question here? It really actually is very straightforward, okay? It's actually just parsing the information you're given because actually I explicitly give you the information that you require in the question for one or two of these questions. So again, let's just recap on a couple of things before we proceed. Let P be the event that the individual drinks Pepsi. Let C be the event that the individual drinks Coca Cola. Probability of P is 0.72. Probability of C is 0.24. And the probability of P intersection C is 0.12. Okay, the last point there is important because that's actually the answer to the first question. Probability of P intersection C means P and C, Pepsi and Coca Cola, which means both. The probability that an individual drinks both brands is given by that expression explicitly, 0.12. Okay, so the gist of this really is just actually sort of taking the time to properly process the information you're actually explicitly given. It was almost a trick question. This one's not a trick question. You have to think about this one. Calculate the probability that an individual drinks neither brand. So essentially what we're going to do here is use the complement rule. The probability of an individual drinking neither brand can be found by the complement rule. So what we have to do is find out the probability that an individual drinks at least one of the brands, Pepsi or Coca-Cola or both. That is the addition rule here. The probability of A union C, which means one or the other or both, is the probability of P plus the probability of C minus the probability of P intersection C. Okay, so that is 0.72 plus 0.24 minus 0.12, and that is 0.84. So we have 84% of our respondents drinking at least one of these two brands. That means that the probability of an individual drinking neither of these brands is the complement of that. 1 minus 0.84, which is 0.16. So, now, exercise C. Are P and C mutually exclusive? P and C, are they mutually exclusive? If you drink one, can you drink the other? Well, we're actually told that. So this is what the question is in the context of what we're given. What does mutually exclusive mean given in the context of the mathematics of it? And that means the probability of A intersection C is 0. Okay, two events are mutually exclusive if they cannot occur at the same time. Okay, but we're actually told that, yes, there are 12% that drink both, Pepsi and cola. So essentially that is the answer to this one. The question here is, what does mutually exclusive mean in the context of probabilities? And is it the case here? No. Okay. Probability of A intersection is not equal to 0, hence that the P and C are not mutually exclusive. Okay, so that's just another case where we're just actually reading the question properly and processing it. And building a correspondence between things like mutual exclusivity and the probability of A intersection B or P intersection C and so on. Okay? So finally, are P and C independent? Two events are independent if the occurrence of one does not affect the probability of the other. Okay, mathematically P and C are independent if probability of A intersection C is equal to the probability of P times the probability of C. Okay, so just recall all our probabilities there. 0.72 for Pepsi, 0.24 for Coca Cola, and the probability of both being 0.12. Okay, so calculating the probability of P times C, that is 0.72 times 0.24, and that is 0.1728. But that is not what the answer to what we know. We know that the probability of P in intersection C, Pepsi and Coca Cola is 0.12. That is not equal to 0.1728, so they are not independent. P and C are not independent. So that's it in a nutshell. Probability of P intersection C, both brands, is 0.12. Neither brand, 0.16, 16%. They're not mutually exclusive, and P and C are not independent. Okay, we'll leave it there.